Hello everyone, welcome to this Ashbourne Maths video and the third in our three-part differentiation series. Today we are going to look at one of the slightly harder exam questions, which is a bit of a classic. You're going to learn to love them. A cuboid has a rectangular cross-section where the length of the rectangle is equal to twice its width, as shown in figure 2. So they've already drawn in these two dimensions for us. How kind. The volume of the cuboid is 81 cubic centimetres. So let's just mark that on as well because they haven't put that on the diagram. Part A. Show that the total length L of the 12 edges of the cuboid is given by, and there's the formula. Okay, so this is a really classic question where you have to use a few bits of information to try and find a formula for either the length or the volume. Okay, now, the first thing I want you to do is completely ignore, this final answer. A lot of people get freaked out by that and they try and get there and crowbar their way through there. Just ignore it. Let's just follow these simple steps. You need to write down formulas for the things that you know. Okay, so we've been told about volume, so we're going to write down a formula for volume, and we're also being involved with the total length of this shape, or the length of the side. So we're going to draw a formula for those two things. So this is going to be my first formula, this is going to be my second formula. So what's the formula for volume? Well, volume equals length times width times, let's call it depth. Okay, so volume equals, what's this, 2x times x using our dimensions. Now, let's zoom in on this cuboid. There is no dimension for this kind of depth here, is there? So we've just got to make it up. And what's going to happen, you might, and again, this is where people go a bit wrong. They look at this final answer and they think, oh no, there's no d in this, there's only x's, so I can't use a d. Do not think like that. We're going to use the d, or whatever variable you choose, and then we're going to eradicate it, okay? So eventually we're going to eradicate this thing, get rid of it. But for now, we're going to use it. So the volume equals 2x squared times d. And we've also been told that the volume is 81, so we can add that into our formula. 2x squared times d equals 81, and there is my first formula. Now, what about the next one? Well, let's think about length, okay? So what is the formula for length? Let's zoom in again on this object. So we've got that length, that length, that length, and that length. So we've got 4 of them. So 4 of the 2x's. We've got this length, this length, this length, and then another one hidden there. So it's 4 lots of just the single x. And then finally we've got 4 lots of this d length as well. Okay, so that, when we add up all of those, that gives us the length of all the edges. So let's put this in a formula. So it's going to be 4 lots of the 2x side plus 4 lots of the x side plus 4 lots of the d side. And now I'm going to simplify that. So I've got 8x plus 4x plus 4d, and L equals 12x plus 4d, and again, I've finished. That's my second formula. Now again, please don't look at the final answer yet, just carry on the process, don't be phased. We need to now do that thing that we were talking about eradicating this d variable, because we don't want that. We've made it up, we don't want it in our final answer. So what I'm going to do is firstly make d the subject of this first formula, formula number 1, and then I'm going to substitute it into my second one. So I get d equals 81 over 2x squared, okay? And I'm going to use this to substitute and eradicate d in the second equation. Okay, so it's just basic simultaneous equation stuff. So this implies that L equals 12x plus 4 lots of, and what we now know is d is 81 over 2x squared. And there, look, I've successfully eradicated that d variable. Let's carry on, and L equals, let's just simplify that fraction. This should be 162 over x squared. And now we can go to, once we finish that, go to our final answer, and indeed our two answers match up. L equals 12x plus 162 over x squared. And hopefully you'll be convinced, as much as I am, that this is quite a simple process and just a bit methodical, and will get you to your final answer. Now let's move on to part B. Use calculus to find the minimum value of L. Now, if you struggle with this first part, that almost always they give you the answer, so you can just skip straight to the second part if you really can't get there. Okay, we know that L equals 12x plus 162 over x squared. Now this is really just a function, isn't it, that's got two variables, so I can kind of plot a graph. Now I don't know how to draw this thing, and quite frankly it doesn't really matter. It's clearly some kind of curve with a minimum point somewhere, right? Because they've asked us to find the minimum value of L. This is a curve of L against x. This is much like just y against x, right? But instead of y, we're using L, okay? That's the only difference. So we're going to just do what we would normally do. How do we find a minimum point? Well, the minimum point is when dy by dx equals 0. But except in this case, it's not y, it's L, isn't it? So dl by dx equals 0. Okay, so it's not actually dy by dx, it's dl by dx. So what is dl by dx? dl by dx equals, and we're just going to differentiate this thing. So it's going to be 12 plus, now, what have I done wrong? I've not written my original formula in index form, so I'm not ready to differentiate it. So let's just move this down here and make sure we do our preparation correctly. L equals 12x plus 162x to the minus 2. And now we're ready to differentiate. dl by dx equals 12 plus minus 2 times 162 times x to the minus 3. Remember, I reduced the power by 1. And let me simplify this. And remember, we want to find the turning point. So this is where dl by dx equals 0. So I'm going to set all of this stuff to be 0. 0 equals all of this stuff. 12 minus 324 x to minus 3. I'm going to multiply everything by x cubed. So 0 equals 12x cubed minus 324. 12x cubed equals 324. And x cubed equals, we'll divide both sides by 12, 27. Now, when you get to this point, you know you're cooking on gas, because 27 is a cube number, isn't it? So x equal, it works out very, very nicely. And when I did this, I have to admit this isn't the first time I've done this question, but when I did this for the first time, I thought, well, that is fantastic. I'm almost certain that I've got that correct. It's worked out really nicely. And so going back to my diagram up here, again, to reiterate, this curve is not a correct curve, but it's just a kind of almost symbol of what's going on here, okay? And this is this point here is x equals 3. Now, you might think we're done, and often a lot of students would stop there. But let's just go back to the question. Use calculus to find the minimum value of L. It's L that we want, okay? So we're actually going to have to substitute back into the equation for L. L equals 12x plus 162 over x squared, and I'm going to sub in x equals 3. So L equals 12 times 3 plus 162 over 4, which equals 36, plus 40.5, which is 76.5. And now I have finished, and I'm going to highlight my answer. And that's it.